Okay, here we go. So here we've got pictures of head lice and fleas. How lovely. So, shows the external features of two insects. Both are human ectoparasites. Ectoplasm comes out of you. So, it's an outside parasite. Anything else we can see? They're both insects. We've both got 3 pairs of legs. They're both segmented. Neither of them have got wings. They both look a little bit unpleasant. Got some claws there. And this one's got big back jumpy legs. Nice. So, define the term ectoparasite. So this is, again, this is a bit of synoptic, isn't it? So this was in our component 3 as opposed to the core. And again, it's AO1 because you're defining. So ectoparasites live on the surface of their host, and then of course the parasite bit is from which they obtain nutrition, causing the host harm. There we go. Unlike fleas, so we're going to compare now. Head lice normally infest a new host only by close contact between individuals. You want to think about that, do you? Suggest one reason. So here we've got this sort of, big back jumpy leg on a flea, but no big back. All these legs are the same size. It hasn't got any jumping legs. So the head louse's legs are all the same size. So it cannot jump like a flea does. State. So that was a little bit of interpretation there, I think. So I think we'll make that AO2. So, state. Why these insect species are classified in the same domain and kingdom as humans. So, remember our KPCOFGS thing? Kingdom, we're all in the kingdom Animalia, because we're multicellular, heterotrophic, like a cell wall, blah de blah de blah. And the domains are the eukarya. Remember, this is the 3-domain system. We've got the eukarya, the prokarya, and the archaea. And both of these have no nucleus. So why are we in the same domain as these insects? In the domain eukarya as a membrane-bound nucleus. Can't spell. Bound nucleus is present in all cells. Why are we in the same kingdom? Because the cells in both do not have cell walls. They're all multicellular and heterotrophic. And here we too, I'm definitely really sure we're using trophic because we are eating something. So there we go. The diagram below shows phylogenetic trees with shades of big nose fish, showing the co-evolution of different species of lice. The dotted lines represent parasite-host relationships. So these are the parasites and these are the hosts. Numbers at branch nodes are the estimated time of divergence, so that's 5.6 million years ago for Pedunculus schaefii and Pedunculus humanus. They diverged from these other two 13 million years ago. That's what it's saying. So these are time, this is a time scale. Right, from a common ancestor in millions of years ago. These times are obtained using a molecular clock. Ooh. So here, I'm thinking molecular clock equals mutation rate. I might need to talk about that later. Supported by fossil evidence, a molecular clock measures the degree of genetic similarity between species. So remember the species that we're dealing with. We're not dealing with the host species, we're dealing with these. So Pedunculus, we've got Thyris, and Dicinus. Okay. And then we've got the same arrangement on the other side. So we've got chimps and humans diverging 6.1 million years ago. Gorillas breaking off at 11.8 million years ago, and the apes diverging from monkeys 24 million years ago. So we've got, okay, hosts and parasites, phylogenetic trees. Couldn't make it more complicated, could they? Describe the evidence that suggests, I'm only describing here, the common ancestor of gorillas and humans was not infested with the pubic louse. Oh, look who the human is. Oh, it's Mr. Darwin. And he appears to have pubic lice. That's quite horrible. So, when we're looking at the host species for the pubic lice, it's going to a human and it's not going to a gorilla. But the gorillas have got the equivalent, which is Phythurus gorillii. They broke away from, so the lice broke away from each other 3.3 million years ago, but actually gorillas broke away from humans 11.8 million years ago. So, I don't know how to explain it. So, let me think. I don't want to write that big long word out either. The pubic louse, but I use it. I'm going to just call it pubic louse, they have. The pubic louse diverged from the, I don't know, I'm going to have to use its proper name, Thyrus gorillae 3.3 million years ago. So this is later than when the gorilla and human diverged. Brackets, 11.8 million years ago. Do I need to say anything else at the time? No. And of course I've put my numbers in because in case there's a little data remark there. So describing evidence, where we're using two sets of evidence, one from each side. I'm thinking that's going to be AO3, might be 2, because it's a describe rather than explain. Okay, suggest. Oh, we're on the last tranche now, the last 3 marks. Suggest how DNA analysis could be used to measure the degree of genetic similarity. What do we know about DNA analysis? The more similar the base sequence, the more closely related. That wasn't really what they were asking me, but I can't think of anything else to put. More similar to the base sequence. Work out the base sequences and look at the similarities. The table below represents a hypothetical molecular clock. Somebody's been making up data. Insert the value for the time of divergence for 90% genetic similarity. So 40% gives 30 million years ago. If they're 60% similar, it's 20. If it's 80% similar, it's 10. So I'm thinking 90% similar. Is there a pattern there? Are you supposed to guess? Are there any clues on here? No clues on the question. I don't know. I'm going to put 5. It's not likely to be 0, is it? Because then you wouldn't have diverged from a common ancestor. You'd be the same. I'm going to put 5. For no good reason, really. I'm putting 5. Don't know why. There we go. Able. So, another human ectoparasite is the disease-carrying body louse. Oh, do you remember those on the video? Attaching its eggs to clothing. Where the head louse attaches its eggs to scalp hair. Suggests why they are the same species. Oh, if they're the same species, they are able to interbreed to produce fertile offspring. I'm pretty much thinking that they would accept any value between. There isn't a pattern there. There's just not a pattern. So, any value between 1 and 9, I would have thought, would do there. So, let's just have a look at the AOs then. So, we should know that. AO1, this is your best guess. AO2, 3, and AO1 for a definition again. Okay, that's it. That's your lot.